In our sky, is this one Betelgeuse or scarab juice? It's a red monster star. On the off chance that you put it where the sun is, it would stretch out to the orbit of Jupiter. It's huge. It's entirely unstable and could be on the brink of exploding, potentially leading to a vast catastrophe of a never-before-seen scale. Scarab juice, the red monster star on the edge of our galaxy, is sending unnerving signals through space. Cosmologists have found something profoundly disturbing about this tremendous object using the James Webb Space Telescope. Notable researcher Brian Cox has given an intense warning. The question that continues to come up is, are we going to witness a supernova blast so colossal that it will change the night sky forever? Let's dive right in. In the immensity of the universe, stars are born, live, and die in astounding ways. Recently, one star has drawn the attention and concern of both cosmologists and ordinary people. This is Betelgeuse, a red supergiant star that stands out in the constellation Orion. It's enormous and very old. Its unique reddish color and changing brightness have long been intriguing, but recent events have made people even more fascinated by this cosmic giant. As we learn more about Betelgeuse, we are on the edge of a potentially significant event in its history. But what might these changes in Betelgeuse mean? Are we witnessing the beginning of a cosmic spectacle on an incredibly vast scale? Betelgeuse is a stellar giant, about 1,000 times larger than our Sun. It is so immense that it's difficult for humans to comprehend. Imagine a star so enormous that, if it were to replace our Sun, its surface would reach past Mars' orbit and engulf Mercury, Venus, Earth, and Mars. This immense size not only shows how extraordinary Betelgeuse truly is, but it also indicates what stage of its life cycle it is in as a red supergiant. Betelgeuse is nearing the end of its life. It's expanding and cooling during this phase, which follows the fusion of hydrogen into helium in its core. But what about Betelgeuse's age? The star is believed to be between 8 and 8.5 million years old, relatively young in human years, but ancient in stellar terms. It has evolved dramatically over millions of years, transitioning from a hot blue star to the red giant we see today. Now, in its final stage as a red supergiant, Betelgeuse is undergoing changes that reveal the complex tensions of nuclear fusion and gravity. Another striking characteristic of Betelgeuse is its intense red color. Its red hue comes from the fact that its surface is cooler than other stars, like our Sun. The Sun's surface is around 5,500 Kelvin, while Betelgeuse's is about 3,500 Kelvin. Since it's cooler, Betelgeuse emits light at frequencies that make it appear red. This color isn't just for show. It tells us something about the star's physical state and the processes occurring within its massive gaseous volume. Historical records from Roman and Chinese times say that Betelgeuse was yellow around 2,000 years ago. In the 9th century, Arabic astronomers noted it as red. This shift in color over human history isn't just a small fact in the history of science, it also shows the star's evolution. Another fascinating aspect of Betelgeuse is that its brightness fluctuates over time. As a semi-regular variable star, it brightens and dims on a regular basis, which has intrigued scientists and skywatchers for centuries. Betelgeuse goes through a 400-day cycle and a longer cycle lasting 6 years. As early as 1836, Sir John Herschel wrote about these cycles, and some indigenous narratives may go back even further. But what truly makes Betelgeuse mysterious isn't just how its brightness changes but also its irregularity. Unlike many stars that dim and brighten predictably, Betelgeuse sometimes deviates from this pattern, suggesting complex, less understood processes are occurring within its immense structure. Recently, astronomers and stargazers worldwide were stunned to see Betelgeuse's appearance change dramatically and unexpectedly, now known as the Great Dimming. In late 2019, Betelgeuse, one of the brightest stars in the night sky and a prominent feature of Orion, began to fade in a mysterious way. The star was losing its light at a rate of 0.01 magnitudes per day on average. By February 2020, it reached its dimmest point. Normally visible even in light-polluted areas, Betelgeuse became so faint that even casual observers could notice the difference. This phenomenon made it challenging to keep a precise record of the star's brightness. Keeping an eye on what Betelgeuse is doing is fascinating, because light takes such a long time to reach us. When we look at a star like Betelgeuse, we don't see it as it is now but rather as it was in the past. The light we see today left the star almost 700 years ago, since it is around 725 light-years away. Because we are investigating the past of the star, this delay makes it difficult to predict and monitor rapid changes in its behavior. The Betelgeuse dimming event was a reminder of how challenging it is to observe the sky in real time and how little we know about the vast, strange realms of reality they reveal. Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely observed Betelgeuse's celestial display as part of a 3-year study to track changes in its outer atmosphere. They used Hubble to examine the massive star, and these observations provided new insights into how a variable star like Betelgeuse operates. Variable stars regularly expand and contract, which causes fluctuations in their brightness. Researchers were able to investigate the layers above the star's surface, which were heated in part by the star's whirling convection cells. Thanks to Hubble's sensitivity to ultraviolet light, further analysis of the Hubble spectra, taken at various times in 2019 and 2020, helped reveal how fast things were moving in Betelgeuse's upper atmosphere. The spectra were mostly composed of magnesium-2 lines, which reveal the nature of the star's atmosphere. The studies showed that material was moving from the star's surface into its atmosphere at around 200,000 miles per hour. This hot, dense material eventually reached thousands of miles from Betelgeuse, marking the beginning of the dust cloud that caused the star to appear dimmer during the 3 months of the event. Dupree and her team estimated that approximately twice as much material as usual was ejected from Betelgeuse's southern hemisphere. While all stars lose mass over time, Betelgeuse's loss was particularly noticeable because it occurred at a much faster rate than the Sun's. Astronomers speculated whether this event could be a sign of an impending supernova explosion, given the substantial mass loss and subsequent dimming. Being roughly 725 light-years from Earth, Betelgeuse's activity adds to the mystery, as any explosion would be visible from Earth, offering people a rare opportunity to witness a supernova up close. However, the question remains, what does this dimming mean for Betelgeuse's future? Is it a sign that a supernova is imminent, or is it simply a one-time event in the star's long and complex life? Several ideas have been proposed to explain this rapid change. One popular hypothesis suggested that Betelgeuse is in a pre-supernova stage. This idea gained traction because many believe Betelgeuse is nearing the end of its life. Another common theory is that dust, possibly from the star itself, is obstructing our view. It's known that Betelgeuse and other red supergiants regularly lose material, which can accumulate into a dust cloud dense enough to obscure our view of the star's light. A third theory examined changes in the star's photosphere. Alterations in the visible outer layer could influence how bright it appears. This puzzle was addressed using various observational techniques and in-depth analysis. Spectroscopic examinations indicated that Betelgeuse's effective temperature had decreased, suggesting the star may be dimming due to a large dark spot on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming supported this idea, indicating significant changes on the star's surface. Ultimately, the Hubble Space Telescope, humanity's sentinel in space, helped us piece together what was happening during this unusual event. Hubble's observations revealed that the dimming of Betelgeuse was likely due to a large amount of hot material ejected into space. This material created a dust cloud that obscured part of the star's surface, resulting in less light reaching us from Betelgeuse. The residue cloud was made of exceptionally hot plasma that ejected from a major convection cell on the star's surface. It traveled through its hot air to the cooler layers outwardly. As it cooled, it formed dust grains, creating a cloud that obstructed light from about a quarter of the star's surface. Hubble's bright light spectroscopic observations, which started in January 2019, were extremely helpful in assembling the events that led to Betelgeuse getting dimmer. These studies provided signs of dense, hot matter moving through the star's atmosphere. Several ground-based telescopes also observed the star getting less bright in December 2019, especially in the southern hemisphere. Initially, the material was brighter than the star itself, but as it moved outward and cooled, it transformed into a dark cloud. The theory suggests that this ejected matter and the shadow it created were what caused the star to dim suddenly. This eruption is quite significant and has put Betelgeuse in the spotlight of astronomy. The star expelled around 400 billion times the mass usually released in a typical coronal mass ejection. This ejected material, estimated to weigh several times the mass of the Moon, was a significant event for both Betelgeuse and our understanding of stellar behavior. What does such a massive outburst mean for theories about Betelgeuse and supernovae in general? It has enormous implications for our understanding of red supergiants like Betelgeuse, which are thought to lose mass at a relatively steady rate before they explode at the end of their lives. However, the scale of this eruption calls this idea into question, suggesting a more turbulent and perhaps unpredictable end of life for these stars. Could Betelgeuse be preparing for its dramatic finale, a supernova explosion, in a few thousand years? New studies estimate that an event like this could happen sooner than expected, possibly within just a few decades. Another important piece of the Betelgeuse puzzle is the concept of a bow shock. This massive star speeds through space at around 67,000 miles per hour relative to the material between the stars. It creates a bow shock, similar to the wave a boat's bow generates when moving through water. This effect occurs when the star's outer layers interact with the gases and dust in the interstellar medium. This bow shock not only informs us about Betelgeuse's current state but also helps us learn more about how stars evolve over time and lose mass. Regarding the star's past actions, it has been observed that after the mass ejection, Betelgeuse's surface cooled and became less dense. This suggests the star remains unstable even years later. Hydrodynamic models show a connection between the star's convective activities, the mass ejection, and changes in pulsation mode that follow. This ongoing instability raises questions about the inner workings of these processes and how they might conclude in the future. Betelgeuse's mass loss rate is much higher than that of many other stars, suggesting that its internal forces interact in a complex way. The forced pulsation contributing to this mass loss is affected by the constant loss of energy through shock heating and mass ejection. These observations demonstrate that Betelgeuse's life cycle is highly dynamic and unpredictable. This ongoing variability forces scientists to reconsider their models of stellar evolution. With all these significant changes, one might wonder if Betelgeuse is approaching a supernova. The question is crucial to astronomers. Although the exact timing of such an event remains uncertain, the recent massive ejection has shifted the conversation, leading some to think the end is closer than previously anticipated. Theories now attempt to interpret what this tremendous loss of matter means for the star's health and future. While astronomers focus on Betelgeuse, the supernova SN 2023X also draws attention and provides interesting comparisons. This astonishing explosion occurred in Messier 101, also known as the Pinwheel Galaxy, just 21 million light-years away. Discovered in May 2023, SN 2023X is not just any supernova, it's the closest one found in recent years, offering scientists a great view of a star's end. It was like a cosmic upheaval when SN 2023X was discovered. Koichi Itagaki, an amateur scientist known for discovering supernovae, first noticed this quickly brightening spot on the edge of Messier 101 with a small 0.35 m telescope. When he shared his discovery, the astronomy community mobilized, from ground-based observatories to the Hubble Space Telescope. Telescopes worldwide watched this new supernova as it unfolded. The race to monitor SN 2023X's light curve provided scientists with valuable information about the explosion and the region surrounding the dying star. In just 5 days, the supernova went from faint to extremely bright, then began a more gradual decline, dimming by 0.03 magnitudes each day. An analysis of the spectrum revealed many bright emission lines, indicating a strong interaction between the expanding supernova shock wave and the surrounding gas. This wasn't merely a star's death, it was an enormous star collapsing under its weight as it ran out of nuclear fuel, ejecting its outer layers in a spectacular core collapse supernova. However, what's truly intriguing about SN 2023X is the thick shell of gas that surrounded it. This made it much harder for the shock wave to escape from the star's core. There are two possible explanations for this dense material around the star. Either a strong, steady wind was blowing material off the star before it exploded, or the star had random bursts that threw material into space. In either case, the star is thought to have lost up to a solar mass of matter in its final 1 to 2 years of life, suggesting its last moments were far from peaceful. The primary goal of research now is to identify the parent star of SN 2023X. Astronomers have utilized various strategies and measurements to construct a probable competitor for a red supergiant. By examining the specifics of the SN 2023 EXF blast, such as the dynamics of its parent star and the processes that led to its final impact, astronomers can improve their models of star formation and supernovae. These insights help us understand what's happening with Betelgeuse right now and how it might eventually go supernova. They give us a better idea of what signs to look for and how to grasp the complex behaviors of enormous red giants. But when will Betelgeuse become a supernova? Tohoku University researchers believe that Betelgeuse may be in the carbon-burning phase of its life, a stage that stars usually go through before they die. Hoki Seo, responsible for this work, believes that the star's core could collapse just a few decades after it depletes its carbon. On the other hand, researchers at Hungary's Konkoly Observatory think Betelgeuse is in an earlier phase, still burning helium. There are different theories, but most agree that Betelgeuse will likely be the next supernova in the Milky Way. However, this event might not happen for another 100,000 years. Studying past supernovae has provided us with valuable information about how stars die. In 185 CE, the earliest known record of a supernova was made. It appeared as a bright star that vanished from the sky after 8 months. Since then, many significant supernovae have been observed, including SN 1604, the largest star ever recorded in the night sky, visible from many places on Earth, and SN 1054, which formed the Crab Nebula and could be seen during the day for 23 days. The most recent supernova found in the Milky Way was SN 1604, which Johannes Kepler studied in detail. More recently, SN 1987A in the Large Magellanic Cloud was observed just hours after its light reached Earth, marking the first supernova to be seen through neutrino radiation and across the entire electromagnetic spectrum. These observations have been instrumental in creating accurate models of supernova behavior and understanding the role they play in star formation. Imagine if the night sky suddenly erupted in a brilliant cosmic display with the explosive brightness of a new star. If Betelgeuse, one of the brightest stars in Orion, went supernova, it would create an extraordinary light show that could be seen for weeks, perhaps even months. Betelgeuse is approaching a core collapse supernova, a type of explosion that happens when massive stars exhaust their nuclear fuel and can no longer support their own gravitational collapse. The collapse would only take seconds, releasing as much energy as our sun produces over billions of years. Most of this energy is emitted as electromagnetic radiation, including X-rays, gamma rays, and visible light. A Betelgeuse supernova would cause an incredible display in the night sky, visible even during the day, brighter than the moon for a time. While it would be amazing to witness a Betelgeuse supernova, its true significance lies in the scientific questions it raises. Supernovae, especially those involving massive stars like Betelgeuse, act as cosmic laboratories, teaching us about the universe at its most fundamental level. Observing a Betelgeuse supernova up close would offer a chance to study the final stages of a star's life. When massive stars like Betelgeuse explode, they scatter heavy elements like iron, formed within the star, into space. This process provides the building blocks for planets, stars, and life itself. Researchers could gain insights into stellar evolution, elemental synthesis, and the creation of new celestial bodies by examining spectroscopic signatures and the distribution of these elements following a supernova. The visible light from a Betelgeuse supernova would be stunning, but just as fascinating are the neutrinos it would produce. Neutrinos are subatomic particles that interact weakly with matter, making them extremely hard to detect. However, the intense environment of a supernova generates enormous amounts of these elusive neutrinos, offering a unique glimpse into the heart of a dying star. Studying these neutrinos could deepen our understanding of the fundamental forces and particles active in a supernova explosion. Tracking and analyzing these neutrinos would represent a significant scientific advance, potentially leading to new insights about the universe's extreme conditions. The discovery of a Betelgeuse supernova could also impact our understanding of cosmic expansion and the mysterious force known as dark energy. In the late 1990s, scientists studying distant supernovae found that the universe's expansion is accelerating, not slowing as expected. Due to its proximity to Earth, a Betelgeuse supernova would provide a valuable opportunity to collect data on the universe's expansion rate and dark energy's role in driving it. This could help refine our understanding of fundamental concepts about the universe and possibly reveal new mysteries regarding its structure and fate. But would a Betelgeuse explosion pose a threat to Earth? Thankfully, because Betelgeuse is so far from us, such a danger is unlikely. 1 light-year is approximately 5.88 trillion miles, illustrating just how vast our universe is. At 725 light-years away, Betelgeuse is over 267 trillion miles from Earth. This vast distance provides a degree of cosmic shielding, making it improbable that the explosion itself would directly harm Earth. Thank you for following this space news update. The incredible footage now appearing on your screen is so astonishing you may not believe it. Take a look.